Hi, this is Kevin Brown. I'm the head of marketing for data centers at Schneider Electric. I'm here with Rich Whitmore, who's CEO of Motivair. How's it going today, Rich?
Great, Kev. Nice to see you.
Good. So I have a topic for you that I'm interested in exploring is NVIDIA. In the not too distant past, announced a 10 megawatt reference design, roughly 10 megawatt reference design. Can you give me some of your insight on how Motivair is approaching uh, cooling this reference design and some of the things that led you to our recent CDU announcement?
Yeah, so I think it's important when we look at AI factories or these large high performance data centers that are coming out to think about it in terms of building blocks. As you look from the chips to the servers, racks, and outwards, everything is really building blocks. And so when we look at, for example, a 9 or 10 megawatt compute load to cool, the last thing that we want to do is go and develop a 10 megawatt CDU, right? It's fraught with risk. There's a lot of issues there with control and responsiveness to these very dynamic AI loads. And so that we approached it again in a building block, almost like a modular fashion, where we took a look at not just the compute roadmaps, but also the power side of the data centers, and we think that 2.5 megawatts is the optimal design point for these types of systems and what we see coming down the road.
So the 2.5 megawatt size that you've committed to, is that only because of what NVIDIA requirements are, or is there power or other considerations that are brought into those decisions?
Yeah, when you zoom out, right, you're trying to create like this optimal system, right? From both power and cooling, of course, compute as well. And 2.5 megawatts is really that sweet spot where you can pull together a 2.5 megawatt power lineup, coupled with CDUs, and then also build these in a highly scalable fashion, right? Where we can build at high volume in multiple different factories around the world. So 2.5 megawatts is really that optimal point to be at.
So it's not only a decision just based off of what NVIDIA is requiring and how they're operating, but also, hey, how do I match it up against power? How do I match it up against everything else that's going on inside the data center? Did I understand that correctly?
It is, and we also take even a broader view. Obviously, we've got a very close and strategic relationship with NVIDIA, but much of the computing ecosystem comes to us for guidance and for support on where things are going in the world. And so, we take all of that into account. And this 2.5 megawatts is really where the future is going to be. But also, if you zoom out on that even further, having additional capacity, depending on where a customer is locating a data center, what type of compute they're putting against it, it also opens up opportunities for additional free cooling and efficiencies from a building cooling perspective.
Yeah, so it's a complex decision process, but when you look at the whole 2.5 megawatts seems like we've chosen as the optimal point, and we've got our own reference designs that we did with NVIDIA that show how this all fits together and matches and how you can easily deploy in modular chunks.
Yep.
Uh, so that's great. So thanks very much for taking the time, Rich. Appreciate
Great catching up, Kev. Talk to you soon.
it.